Hello everyone, I'm Adam. In this problem, we're going to be finding the component form of a vector v given its magnitude and the direction that it makes with the positive x-axis. So for our vector v, we're told that its magnitude is 3 and the angle theta that it makes with the positive x-axis is 0 degrees. Now there's two ways to approach this problem. We'll start with a simpler way and then not very complicated, but we'll call it the more complicated way. So the simpler way is simply to make note using the two pieces of information that we're given. So suppose again, what we're given is some magnitude and some direction. So for some vector in general, not the v that we're talking about here necessarily, but some vector v that makes some angle theta with the positive x-axis and has some length, which we call the magnitude of v. If you remember polar coordinates, so this isn't truly polar coordinates, but this is kind of using that same idea. If we go up an angle and out a direction, we get to a given point. Namely, we'll call this v1 and v2. And those coordinates is what we're trying to find to write the component form of v. So the easy way with what we're given is to take a look just using those two things, the angle and the direction. So starting over here with our angle, we know that theta is equal to 0 degrees. So then the angle that our vector is going to make with the positive x-axis is pretty much going to stay right on the positive x-axis because it goes up 0 degrees. So we're staying on the positive x-axis, and from our initial point at the origin, we're going out a magnitude of 3. So out a length of 3. So that is going to signify our vector v. So at our terminal point, at x equals 3, y equals 0, we can write this in component form as the vector with components 3, 0. Okay, so that's what our vector is going to look like in component form. So that's one way of doing it. Let's take a look at a different way. So the different way of doing it is, again, let's consider some vector say call it v, making some angle theta with the positive x-axis. And again, what we're looking for is essentially the coordinates of that terminal point v1 and v2. So how can we find that? Well, if we take a step back for a moment and consider the unit circle inside this xy plane. So inside of our unit circle, what we have is, say, the unit vector u of length 1, or magnitude 1, that's coinciding or going in the same direction of our vector v. Vector u. Okay? Now, how can we use that? Well, what do we know about the unit vector going in the same direction as our component vector v? We know how to find that, namely with the formula u is equal to 1 over the magnitude of v times v. Now, of course, we're interested in finding v. So rewriting this formula, multiplying both sides by the magnitude of v, which again is just a scalar, it's going to be the magnitude of v times u, magnitude of v times u equals to v. Okay, so looking at this, seems like we're given the magnitude of v, all we need to do is find u. Well, one thing that we just have to remember from trigonometry is when we're looking at the unit circle, any point, or take a look at the terminal point of our unit vector, any point on the unit circle can be written as x value as the cosine of this angle theta, and y value is the sine of the angle theta. So u can be written in its component form as cosine theta sine theta. Okay? And so that's what we're going to use. So using this little formula with this substitution is how we're going to find v. So let's go ahead and do that. So we're taking the magnitude of v, right, times u, which we'll write as the component form, cosine theta sine theta, okay, which is equal to, say, our magnitude of v. Now, instead of this component form, what we're going to do is write this as the linear transformation of the components and the unit vectors I and j. So we can write this as cosine theta times I plus sine theta times j. And now we're about ready to start plugging some things in. So the magnitude of v we know is 3, and this is times cosine of 0, or 0 degrees, times I, plus the sine of 0, or 0 degrees, times j. So cosine at 0 is positive 1, and sine at 0, right, is 0. So now multiplying through with the constant 3, we get 3 times 1 times I, or just 3 times I, plus 0 times j, but 0 times anything, including vectors, is just 0. So this is just equal to 3 times the unit vector I, which, what is that? That's equal to 3 times the unit vector I, which has components 1, 0. And so taking a scalar times a component vector, we just multiply each component by that scalar. So this is equal to 3 times the component 1, which is 3, and 3 times the component 0, which is 0. Which, as we see, we get the component vector 3, 0, which is exactly what we got over here in part 1. So thank you very much.